yeah, we never try to coin ourselves as the Chainlink killer. I think there's plenty of room for multiple solutions in our space, and we sort of take the approach of just connecting APIs to the blockchain, whereas Chainlink has this more generalized model where basically you have this Oracle network in between any data source and the blockchain. So we're kind of coming at it from a different angle, and yeah, but like PR is PR, and like the reporters get to choose the title themselves, so not much we can do.
It takes a bit the mystique away that in the blockchain world for the last 2 or 3 years, there's always this discussion about the Oracle problem, and it was really mythical, hard to understand how to resolve it. And you kind of take a very sober approach to that and say, well, it's APIs. We're taking original data sources and bridging APIs into a decentralized world, which sounds plain and simple, if I can put it this way.
Sure, yeah. Well, that's mostly what these Oracle solutions are being used for right now anyway. So essentially taking data from multiple APIs and then relaying them onto an aggregation contract on chain, which sort of acts as the consensus engine in the sense that it gets rid of outliers and then aggregates that into a single value that can be used to execute a smart contract. So essentially what we're doing with API3 is just getting rid of the third-party node operators as the middlemen and having the data providers themselves operate this very simple API gateway that enables their API to be called by Web3 applications and smart contracts. So instead of having the structure where you have the aggregation contract on chain connected to this very decentralized network of nodes that is then connected to the data sources, we basically connect the aggregation contract to the data sources directly, which gets rid of this sort of over redundant layer of nodes, which doesn't really provide additional decentralization against anything other than it itself. Like if you take decentralization as a security metric, where the more decentralized a network is, the more difficult it is to hack it. So the more difficult it is to manipulate through a Sybil attack or a collusion attack. The only Sybil attacks and collusion attacks that the Oracle network is protecting against are Sybil attacks and collusion attacks against itself. So if you get rid of that whole network of nodes, what you arrive at is the same level of decentralization that you had in the first place. So essentially the decentralization is determined at the level of the data sources. So if you're using 5 APIs that are connected to this decentralized network of nodes that is then connected to the aggregation contract, you'd have the same level of decentralization if you just had those 5 APIs running their own Oracle nodes and then connected those directly to the aggregation contract. So what I'm getting at here is that basically, it obviously becomes more difficult to attack the Oracle layer if you have more nodes in it, but the most secure approach is that you have the actual data providers running the nodes themselves.
Plus, the argument was also one of transparency. So if you have the data providers running the nodes directly, you know exactly who's behind that, while if it's clouded in a middleman or middlewoman for that matter, then it's not quite clear what the quality of the data source in the background is.
Yeah, exactly. So like you can't treat the middleman as the source if it's not the factual source of the data. So it doesn't matter if you have 21 nodes connected to an aggregation contract if those 21 nodes are on the back end connected to a single API. And if you don't have transparency all the way to the source level, then it's difficult to estimate what that true level of decentralization is. And you end up trusting whoever put that data feed together. So there's always sort of a managing party or a governor of that data feed. And in the case of these existing solutions is often the core team that puts these decentralized data feeds together, and then they decide how many APIs get used and which nodes they connect to. But if you basically make the data source level opaque, then you're just essentially trusting the core team that they have some adequate level of decentralization in place there. Whereas if you use first-party oracles, you can always see where the data is coming from. And ideally, you would even go to the source level with the API. So you'd use exchange APIs instead of like aggregated APIs. But and then you do aggregation on chain. But yes, it provides a lot more transparency into the process.
You know, certainly different solutions for different problems. But when we arguing about capital markets, or in this case, of DeFi application in particular, where we're relying on pricing, financial data, typically one wants to know exactly what the data source is and make a judgment as to what is being used. And so it seems to be tailor-made and very good fit for this type of application.
Sure. Yeah. I mean, it provides that transparency. It provides a bit more security in the sense that you don't have to actually, even if you have a very decentralized Oracle layer in between, there's always some level of risk of there being some sort of collusion or Sybil attack, whereas you don't have those risks at all when you work with the first-party data providers and the node operators, and then also you get the added level of transparency into the whole process, in addition to also sort of aligning the financial interests in this whole structure. So instead of a lot of the compensation going to the middleman, you can actually flow that compensation all the way to the source level. So it also incentivizes the data providers in a better sense, because right now, if a node operator, one of these third-party node operators, is connected to an API, they usually do it through just one of these Web2 API subscriptions, and those aren't really scaled for Web3 use. So you can actually provide data to a blockchain use case with oftentimes even like a freemium plan, because they include enough calls for the sort of the number of transactions that currently take place in Web3. So, you know, the number of transactions in Web3 is orders of magnitude lower than it is in Web2, which enables Web2 subscriptions to be used in very cheap rates in the Web3 environment. So what you don't get is, first of all, you don't really get the even the permission to use the data in any sort of resold fashion or sort of like a production manner. But like you also don't get any sort of service level agreements or anything like that. So so when you actually work with the data provider themselves as the node operator, you have a little bit more you have a better ability to be ensured of a high level of service than if you're using like a freemium API key or a very low level plan.
And then you also have the airnode, which seems to be like the standardized infrastructure, so that when I'm a data provider, I don't have to go and figure out how to build that. That's basically provided as an open source construct, and everybody uses pretty much the same, rather than different people having slightly different technical variations.
Yeah, so you essentially create this Oracle integration spec, and then you deploy the airnode on whatever cloud provider you're using for the API itself. So sort of the API gateway that enables the API to be called from Web3 applications sort of becomes a part of the API itself. And that takes, you know, less than a day. The actual deployment takes like 3 minutes to deploy an airnode, and you can deploy it for free and then scale up in terms of like security and the services that you use based on the actual demand for your API data. But you can essentially already deploy an airnode and then just sort of have it running for when that demand appears, because you sort of have this chicken and egg problem in the Web3 space where you don't have a lot of demand for a certain type of data. Then the data provider isn't really incentivized to deploy an Oracle node that would enable smart contract developers to connect to the API. And if that API isn't connectable, then again, you don't have the developers who would want to build on something that isn't even really available for them. So it solves that chicken and egg problem by enabling the data providers to deploy this simple serverless function that is free to operate and set and forget. And then once that demand comes around, it enables them to, first of all, monetize that demand but also provide it in a very sort of secure and controlled fashion. So they retain the control over their data instead of having a third party resell that data to the consuming party.
One of the things that came out on your blog as well was that some of these data providers are old-fashioned traditional companies who might not have had exposure to crypto yet and maybe are not comfortable legally transacting in it either. So they would prefer not to be involved in paying for gas fees or even getting the rewards in crypto. So how is that being handled? Where does the crypto to fiat conversion take place?
Yeah, so we've been working with API providers for quite a bit here. We built this API marketplace called Honeycomb, which listed more than 20 APIs in the time that we ran it. And that was basically powered by the Chainlink decentralized Oracle network. And we took a lot of lessons from what we did with Honeycomb into API3 and all the discussions that we had with API providers. And for the most part, yeah, the API providers are very focused on the type of data that they provide. So whether API providers are mostly focused on getting the most reliable weather data for an area instead of things like blockchain and smart contracts and cryptocurrencies, they don't really know anything about those. And so any solution that you provide for connecting their API to that market needs to sort of work on that level of knowledge, and they can't assume that the data providers know a lot about the technology that you're connecting their API to. And sort of the existing solution for that is that you have a third-party team operate the node for them, which enables them to sell the data to these use cases. But then once you do that, you sort of the connection point to their data is the third-party Oracle instead of the API. So they essentially lose control over who gets access to their data, and also the data is mainly monetized by the third-party Oracle node. So there's this this problem of control that takes place. But then also, like you said, the data providers traditionally aren't very excited about dealing in crypto. There's a lot of volatility. You don't know how to actually report it in your taxes, and also how to actually maintain it in your books. So any solution that would provide a scalable way of data providers being able to provide their data to Web3 needs to take that into consideration, and the data providers shouldn't have to deal with crypto. So the way that the airnode does that is by having the data requester pay for the gas fees. So there is essentially a crypto wallet in the airnode that gets funded by the requester, and then those funds are used for the gas fees. So actually the data provider themselves doesn't need to deal in crypto at all, and the requester pays for the gas fees always. But that's just sort of part of the solution. The other part is that you don't actually need to know anything about crypto or smart contracts to run an airnode. So for the current solutions, for the most part, you need someone who knows a thing or two about smart contracts, and not only smart contracts in Ethereum, but also the actual Oracle solution that they're employing if they want to run the node themselves. And since that is quite a bit of learning that needs to be done, or like education and knowledge that needs to be available to the team, it's not really feasible to expect that most of these API providers will either learn those things or hire a full-time smart contract developer to run this Oracle software for them, which then again necessitates this third-party Oracle approach. The airnode is just a very simple serverless function that is set and forget, so the data providers can deploy that without knowing anything about smart contracts, Ethereum or Oracles. And it's we basically position it as an API gateway instead of an Oracle node, even though it's called airnode, but that's mainly towards the blockchain industry, so they know what they're dealing with here, essentially an Oracle node. But in reality, it's just a very simple API gateway for the Web3, so they get access to the API.